If you're a .NET developer working with databases, you've probably worked with Entity Framework Core. But what about Dapper? Hi, my name is Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In this video, we're going to be looking at the repository pattern using Dapper. This video is part of a larger playlist that focuses on the repository pattern and caching as well, so I'll have a link to that right up here, and I do recommend that you check this out from the beginning if you're not familiar with the repository pattern, Entity Framework Core, or Dapper. And this way you can see these pieces come together. As we explore Dapper in this video with the repository pattern, this will build upon the other videos, so I'm going to be glossing over the interface that we have for the repository pattern. I'm not going to be going through all the nitty-gritty details about why I picked those interface methods, and if you want to understand that better, you can start from the beginning of this playlist with Entity Framework Core. Now, if all of that sounds interesting, just a reminder to subscribe to the channel and check out that pinned comment for my courses on Dome Train. Let's jump over to Visual Studio, check out Dapper and the repository pattern. So in this video, we're going to be using the sample application that we have from the prior videos. It is going to be using these minimal APIs on this ASP.NET Core web app. I do have a comment here that these are not really what you should be doing. This is just so that I can show you it in the browser very quickly when we go to walk through and debug some of this. The idea is that we have what's called a CRUD application. So we can create, we can read, we can delete, and we can update as well. And these are all going to call methods on our repository pattern. And then from there, we'll see how we use Dapper in order to hook up to a SQLite database. Starting from the top, if we want to go wire all these things up, if you've watched the previous videos where we were doing this with Entity Framework Core, we have a generic repository interface. I'll quickly jump over to that just so you can see it. And when I say generic, I mean the entity that we're using with our repository is going to form the type parameter for this generic repository. So if I jump back to program.cs, and how we had this all wired up in the previous videos with Entity Framework Core was done on line 4. So what we used to have was set up, and then we had Entity Framework Core, CRUD generic was what we left off with. But now we don't need to use Entity Framework Core. We can literally swap everything out to use Dapper. And I'll show you the implementation of this extension method in just a moment, but the entire idea is that we can swap out the entire implementation of the repository. None of the other code here has to go change, and we should be able to go run our application with an entirely different repository. This repository still will point at a SQLite database, so the backing database is the exact same, but the technology, the ORM or Object Relational Mapper that we're using is Dapper now instead of Entity Framework Core. And I'll walk through in just a moment what Dapper looks like and some of the reasons why I enjoy using it. To understand how the dependency injection works, we're going to jump into this little extension method I wrote. We'll see that we're adding a singleton repository. It is going to be the generic repository that takes in the entity type, and this entity type is from the previous videos. If you were building a real application, say like a blog, you might have a blog entity, or if you had a website with products, you could have a product entity. I just have a generic entity here for the sake of demonstration, and then the implementation is going to be this Dapper repository. Now for our Dapper repository, it needs to take in a factory method that allows us to create and open up connections. So right here, we can see that I've defined a function that returns a DB connection, and this is just going to be a callback that we can provide in. All that it's going to do is open up a SQLite connection, so it creates it here. With the connection string, this just points to testDB. If you look in my Solution Explorer on the left, you can see testDB right there. I also have it opened up in another program. And then the next line, we open up the connection and return it. So that's this callback function, and we pass it into the repository. This code right here just wires up onto the dependency injection framework that we're going to be using a specific implementation of iRepository, and it's our Dapper implementation. If I jump back to program.cs, you can see that we're calling it right here on line 4, and that's all that I need to change to go from the Entity Framework Core implementation to the Dapper one. But of course, we have to go look at the Dapper implementation to understand what it's doing, so we'll jump over to that next. So if you've never worked with Dapper before, one of the major differences between Dapper and Entity Framework Core, at least from a usability perspective, is that it's a lot more like using SQL directly. For many people that are using Entity Framework Core, I think one of the primary reasons that people love to use it is that you don't really have to think about SQL. Entity Framework Core is super powerful, and if you really need to dive into raw queries or actually working with SQL, it has all of the tools and capabilities to do that. So when I'm explaining this stuff to you, and I've mentioned that I like Dapper personally better, I'm not saying that Dapper is the better tool overall. I'm not saying that Entity Framework Core is bad. I get a lot of flack for this online, but it's just a personal preference. And the personal preference comes from the fact that I do like having SQL queries. Some people hate it. For me personally, I like having them in front of me. I like being able to tune them and tailor them directly. And yes, I know you can do this with Entity Framework Core now, but Dapper just happens to be the thing that I go with. And I figured one of the reasons that making this series would be a lot of fun is that you can compare and contrast the two. And I'm not trying to tell you to pick Dapper over Entity Framework Core. I just want to show you what the two implementations look like, and then you have some more information to go with. This is just a brief interruption to remind you that I do have courses available on Dome Train focused on C#. So whether you're interested in getting started in C#, looking for a little bit more of an intermediate course focused on object-oriented programming and some async programming, or are you just looking to update your refactoring skills and see some examples that we can walk through together, you can go ahead and check them out by visiting the links in the description and the comment below. Thanks, and back to the video. What we're going to see in this CRUD repository that we have, again, create, read, update, and delete. We're going to start with a read, which is going to be a get. What we need to do is open up a new connection. So that's going to use our factory method that we passed in. We'll just invoke it to get a newly opened connection. And then from there, we're going to use a Dapper method. And Dapper has a lot of extension methods that are added right onto the connection interface. So we can say query first or default, and it's an asynchronous call. And then we provide in the SQL query that we want to use. The next set of parameters is going to be the parameters to the SQL query that we want to go run, and then we can provide a cancellation token as well. If we look at the SQL query, it's going to be asking for two fields coming back, the ID and the value. The table that we have is called entities, and then we're just going to match on the ID. And you'll notice on line 25, that's where we provided in the parameter, which is the ID of the entity that we want to look for. So Dapper, because it's an ORM, knows how to go map these two properties into, if I jump to this entity class, into here. So you see ID and value as well. So it does that sort of magic for you. You'll notice that I don't have to go take the result out of here, use a database reader, read out the columns and things like that, and then try to go map that to the object directly. It just does that magic for you. So in my opinion, this is sort of the best of both worlds that I like because I get my SQL query. Because like I said, personally, I like to use that. And then it does all of the mapping for me without me having to do some of that tedious work. Now, Dapper has a bunch of other extension methods that will look very similar to some of the link things that you might be used to. So I was using query first here. You could do query single. And it's, again, just very much like the link extension methods, right? So query first, query single, we have the default part. You can do it synchronously or asynchronously. So lots of familiar options that you're probably used to if you're used to link and Entity Framework Core for that matter. Next up, we're going to look at get all async. It's going to be very similar. Like all of these, we'll start with opening up a new connection. We're just going to use a different Dapper method. So we can see that we're calling query async, and we're passing in the entity type. This is going to give us a collection back of all of the things that match. So because our SQL query doesn't even have a where clause, it's just going to get the ID and value from the entities table. That's then going to get pulled into an IEnumerable, and we're going to list it before going back. You could use toArray if you wanted to as well, but the idea here is that we're going to materialize this collection. When I say materialize, I mean taking something that we can enumerate over and pull it all into memory. I want to call out that this might not be something you want to do depending on your database and the entities that you're working with. So a common theme as you're watching through all of the videos on this playlist as I start putting more and more together is that some of these things will make sense in some context. In other contexts, it will make absolutely no sense to do. If I had a product database with 10 million products in it and someone called get all and then pulled all of that into memory, probably a big no-no. However, if I had some repository and that was going to be a small set of things that I knew was going to be capped at some amount, and I was comfortable pulling that into memory, then I might be totally cool with calling get all async. And in future videos, we'll look at caching as well. The caching concept is going to come up here again. I just wanted to call out that if you're looking at this code and saying, okay, here's a repository pattern. I'm just going to copy and paste all the code I see on the screen. Please consider what get all async would do if you're materializing it into a collection. If you just wanted to iterate over the entire thing with an IEnumerable, there are ways to do that, but I just wanted to call it out so you don't go blindly copy and paste. If you notice so far, the common thing between both of these is that we're using a Dapper extension method and we're using a SQL query right inside the code here. Next up, we're going to look at create async. So connection gets open, then we're using a SQL command here to insert into entities, right? So it's not querying, we're going to insert. We have the SQL syntax here, but now we're passing in two parameters. We have the ID and the value of the entity that we're working with. So slight difference here, and you'll notice that we're not returning back a new entity, we're just putting one into the database. Next up, we'll move over to update, and update is always an interesting one because in some cases, people want an update method that's like an upsert or insert or update, right? So you might say only update if the entity is already there with the same ID, or sometimes you'll say, hey, it's not there, okay, add it. Like, I just wanted to make sure this data was put into the database, so updating or adding. In this current implementation, if you look closely, it's just an update, right? So this where clause that we have right here will guarantee that if we don't find something, we're not going to be matching anything and therefore not updating anything. So that's why this returns a Boolean, and the return value of execute async is essentially going to be the count of rows that were affected. If we've updated any rows, that means we're greater than 0, that's going to return a true. If you want to go implement your repository pattern in a different way, this isn't like written in stone that it has to be done this way. You may have different use cases, so this is all just an example of what you could be doing with your repository pattern. But finally, let's move on to delete async. We can see that it takes in an ID, so we don't need the entire entity to go delete it. We just need an ID of the entity to work with. Again, we're going to use this execute async method, and we're going to say delete from entities where that ID is the ID. All of these are very similar in nature. We have some that are pulling data back. We have some that are executing something, but one of the big things you'll notice, especially if you're familiar with Entity Framework Core, is that we have to look at SQL here, right? When you're using Entity Framework Core, all of the SQL is kind of hidden from your eyes. If you want to go see it, you can find it or you can work with it. But I think, like I was saying earlier, one of the reasons that people really gravitate towards Entity Framework Core is that they don't have to be having their brain thinking about SQL. So there's pros and cons and personal preferences involved. And for me, a lot of the time, the personal preference here is just the usability of it because I enjoy doing it this way. But from here, we're going to go ahead and run this, and we're going to go see these methods get executed from the web API. But I did want to call out that I tried this earlier before recording the video, and I know that it's not going to work already. And it's a really interesting problem, but I'm going to press play and show you what's up. Okay, so at this point in time, everything is technically running. If we have a quick look at the console output here in Visual Studio, you can see that it is in fact listening. So the HTTPS version is on 7230 for the port, but let's go ahead and run this. Because it's a CRUD API, I'm going to go ahead and go to create, and we get this ID back. What I'd like to do is just demonstrate to you, and fair warning, it's going to get very bright very soon. Boom. If we go refresh this, so we have the ID right above, and you can see if I refresh, then you can see that we have this 8520374424, and this GUID that's put to a string ends in 9AC. We can see that's the right value. So this did get inserted here. I'm going to go ahead and copy this out, and I already have it on my clipboard technically, but what we can do is go read this back. So if I go use ID equals and paste this in here, this is going to call our get method, passing in the ID, which is then going to call into our repository. But this is where things are going to break. Here we see that we're getting an exception, and I wanted to have a quick look at this because it's a very interesting problem, and I think that it's something important to think about if you're trying to switch between implementations of things. So you can see that the error says a parameterless default constructor, or one matching the signature int 64, which is a long, and system string value is required. So we need a long and a string as the two parameters to our entity. Okay, sounds interesting. I know we have an ID and a value, so it wants a long and a string. But if we go jump into entity, you'll notice that it's just int. It's not a long, it's not a 64-bit integer, it's a 32-bit integer. The string is the right second parameter that we have to the constructor here, but something's up with the ID. Why are these different? So the reality is when we were using Entity Framework Core, we're using a different ORM. It's mapping things differently. In fact, the driver that's underneath that's calling the SQL could be a different implementation than the one that I'm using with Dapper. So we have two ORMs and they could be using different SQL drivers underneath. So we have completely different call paths even though they're meeting the same interface. Yes, they're both SQLite and yes, they're both ORMs, but they can still have different behaviors, even though technically the queries are going to look the exact same. What I would like to do here, just to keep this demonstration going, is that we're actually going to change this to long, and on our base entity, we're going to change this to long. And I've already tried this, so the rest of the application already compiles just using longs, so not really a big deal to worry about here. But I just wanted to mention this because if you are working in a real code base, in a real big application, and something like this happens where someone's like, hey, we can just go ahead and swap this out because the interface is the same, and it's technically the same database. Not so fast, right? This is a good reason to have functional tests over things. As much as I love unit testing, some type of functional or integration tests that actually exercise the SQL calls will make a huge difference catching things like this. Let's go ahead and run this now. Okay, now that we're using long values, if I press enter on this, we should get something back, and we sure do, right? It ends in 9AC, just like we were saying before. So now we can go ahead and we can update this. An update is going to take an ID and a value. So if I go value equals dev leader and we say enter, we should hit our breakpoint that I forgot that I left on here. And it says true because it did update it. If we try to pull it back now, right, it says dev leader inside here. So all of this is working as expected, and we should be able to do a delete, and we get a true. And that means that if I go ask for this thing coming back here, so back to this, we should probably get a white screen. And we get a very white screen. So this is just a very introductory look at using a repository pattern with Dapper. A reminder that Dapper is really getting us focused on looking at SQL queries and being a little bit closer to the data that way. It's my personal preference, but it might not be yours. Entity Framework Core is an absolutely awesome option. It's probably the most widely used one, so there's a lot of good reason for that as well. And if you haven't checked out the previous videos, just a reminder, they're in the playlist for this, and I recommend that you go check those out before continuing on, because at this point, we're going to start looking at some other things, like caching. If that sounds interesting, stay tuned.